Morning, everyone. I'm Zhipeng from Yasuyuki, and today in this paper we present a method to do radiometric calibration for internet photo collections. Here is a camera processing pipeline. An emerging object reflects sound light, and its irradiance is then captured by the camera, which then undergo a nonlinear processing step, and we have the final observation value. So the purpose of radiometric calibration is to estimate the inverse response function, so we can recover the irradiance from the observation value. And recovered irradiance is quite valuable for applications such as photometric stereo and intrinsic image. So a conventional way to do radiometric calibration is to use a set of 90 images taken by one camera on the different exposure time. In this case, the irradiance ratio is only related to the exposure time. So if we stack all the observation value into a matrix A, a correct inverse response function should map the matrix into a irradiance matrix. Then we ignore all the terms are the same. So the irradiance matrix finally becomes a rank 1 matrix. So the problem actually turns into a rank minimization problem. Unlike conventional method, our problem faces two challenges. The first challenge is the internet images are taken at different viewpoint under different illumination. And the second challenge is that we are trying to calibrate multiple inaccessible cameras at the same time. So here is the pipeline for our method. I will introduce the details afterwards. First is our key observation. We found that for pixel pairs with the same normal but different albedos, their irradiance ratio is only related to the albedo ratio. So to find the correspondence, we project from 3 points to 2D images using struct from motion and multi-view stereo technique. So suppose that we can find sufficient enough such pixel pairs. Like here, we use p-pixel pairs in Q images, for example. So if we stack these pixel ratios into a matrix, the matrix is definitely not a rank 1 matrix. So according to our key observation, a correct inverse response function set should map the pixel ratio matrix into a irradiance ratio matrix, and we cancel all the terms are the same. So the irradiance ratio matrix becomes a rank 1 matrix as well. So the problem then turns into a rank minimization problem again. But the difference is that here we are trying to estimate for all the inverse response functions at the same time. To validate our method, we collect 3 datasets. Each dataset is a mixture of internet photos and images captured using a control camera. The first dataset contains 55 images. And the second dataset contains 44 images. And the third one contains 31 images. And here are the results. As you can see that our method clearly outperforms both a single image calibration method and the radiometric calibration method using photo collections. Notice that our method can only solve all the inverse response functions up to the same ambiguity, which is also a common problem for radiometric calibration using ratio constraints. That's all. Thank you.